NCERT Physics Class 11, 7th chapter, which is System of Particle and Rotational Motion, question number 7.10. In this, we had given that in part A, find moment of inertia of sphere about tangent to the sphere. In this, we are supposed to find the moment of inertia, and the condition which is given to us, that is moment of inertia about diameter, is given as 2 by 5 mr square, where m is the mass and r is the radius of sphere. So moving to part A, we can say that we are supposed to find the moment of inertia of the solid sphere, and the condition is that the moment of inertia about any of the diameter is given to us, which is 2 by 5 mr square. So we can say that this diameter is passing through the center of mass, so we are given the moment of inertia about center of mass. Now we are supposed to find the moment of inertia about an line which is tangent to the given solid sphere. Line behave as a tangent with given solid sphere, and we are supposed to find the moment of inertia about this tangent. So clearly we can use the property of parallel axis theorem, which says that if an axis which is parallel to axis passing through center of mass, then moment of inertia about parallel axis can be written as moment of inertia about any axis which is parallel to center of mass can be written as ICOM plus mt square, where the d is the distance between both the axes. In this situation, the distance between both the axes is capital R. So the moment of inertia about an axis which is acting as tangent to the solid sphere can be written as I parallel is equal to ICOM plus mt square. The moment of inertia about center of mass in this situation is 2 by 5 mr square plus mt square. The value of d in this situation is r. So moment of inertia about an axis which is tangent to the solid sphere can be written as 7 by 5 mr square. Now the second part, which is B, in the second part we want to say that moment of inertia of disk of mass m radius r about diameter is given as mr square by 4, and we are supposed to find the moment of inertia about an axis normal to the disk and passing through point on the edge. So a disk is given to us. The part moving to part B, a disk is given to us, and moment of inertia of this disk about moment of inertia of this disk about an axis passing through diameter is given as mr square by 4. So this moment of inertia is given as mr square by 4, and we are supposed to find the moment of inertia about an axis which is passing through the edge and perpendicular to the plane. So we are supposed to find about the moment of inertia about this axis. A dot means the axis is perpendicular to the plane and passing through the point which is on the edge. So we are supposed to find the value of I. So in order to find the value of I, we can say that by using the parallel axis theorem, you can find the value of I if you know the value of ICOM. ICOM is the axis which is passing through center of mass. This axis is also passing through center of mass, but between this axis and this axis we cannot use parallel axis theorem as both are not parallel. So in order to apply the equation of the condition of parallel axis theorem, we have to consider the another axis which is perpendicular to the plane and passing through center of mass. So due to symmetry, in this we are going to use the another concept which is perpendicular axis theorem. So first, by using the condition of perpendicular axis theorem, we can find the value of ICOM. So ICOM, perpendicular axis theorem, says that moment of inertia about any perpendicular axis can be written as, so let's say this is IZ and this is IY. Similarly, due to symmetry, IY is equal to IX. So ICOM can be written as IZ is equal to IX plus IY. So from this we can say that IZ is equal to IX, which is equal to mr square by 4, and IY, which is also mr square by 4. So from this we can say moment of inertia about z axis is equal to mr square by 2. which mean the axes which are going to consider in this situation are, this is x-axis, this is y, and the perpendicular to both x and y is taken as z-axis. So ix plus iy can be written as iz by using perpendicular axis theorem. And due to symmetry, ix is equal to iy. In this situation, iy is given, that is equal to mr square by 4. So ix would also be mr square by 4. The value of iz comes out to be mr square by 2. Now, if we know the value of iz, we can find the value of I by using the parallel axis theorem. Now you are going to say that I is equal to iz plus m into d square. The value of d in this situation is equal to r. So we can say that this implies that I is equal to iz, which is equal to mr square by 2 plus m into r square. So from this we can say that the value of I comes out to be 3 by 2 mr square.